is it's a permutation. How do I know it's a permutation? It's because it says they're trying to put them in order. So there are two different types of people here. There are permutations. And there are combinations. On your formula sheet that I handed you for the last test, you might have seen that weird looking thing that looked like this. The P stands for permutation. And then this one right here, the C stands for combination. So for a permutation, the formula looks like this. It says n factorial. Oh, and we've already talked about factorials before. Over n minus r factorial. My pen's getting a little sensitive. And then for combinations, your formula is n factorial over n minus r factorial. So it's the same thing, okay? But you have to tack on an extra r factorial. So n minus, there's supposed to be a minus right there. My pen's not wanting to put it in. Yeah, let me erase that. N minus r factorial goes right there. Let's try starting over. So n factorial over n minus r. That's grabbing it together. Try again. I'll scooch it over. Okay, so those are my two formulas. When we are talking about permutations, the order of the things matter. What do I mean by that? So, like, let's say that you were giving out some prizes, and you had first place, second place, third place. The order matters, okay? Or let's say that we were going to elect some officers in this class, and we had a president, a vice president, and a secretary. The order matters. Or if you were dealing with a password, the order matters. Okay? So the letters of a password, the first letter has to come first. Combinations, the order does not matter. Okay? Order does not matter. So this would be things like a committee. If I'm going to form a committee of people, I'm not having any offices in my committee. I'm just going to have a committee. Okay? So your problem said that we had a parade. And there were 4 floats that we were going to put in the parade. And the question was, how many different ways could we order the 4 floats? So we know that the order is going to matter because you've got to have the first float, the second float, the third float, the fourth float. So there are 2 ways that you can think about it. You can think about it just kind of using your common sense, you know, sort of thinking about the problem. So if you picture it, here are the 4 floats in the parade, right? So I've got 4 floats. There they are in line. So when I go to put the first person in the first spot, how many choices do I have for that one? 4. Okay? Well, I've used one of the people. I don't know who it is. It doesn't matter who it is, but I used them. Okay? So when I go to put the second person in the parade, how many choices do I have?
3.
I only have 3 this time. When I put the third person in the line, how many choices do I have to pick from? 2. And the last one is 1. So this is 4 times 3 times 2 times 1. So that would be 12 times 2, which is 24. So there are 24 different ways. Okay, so that's one way to work that problem. But the reason why I wanted to put the formulas up there is I want to show you how to work this problem with the formula. Because guess what? You can work it with the formula. So let's look at working this with the formula. And I'm just learning, my friends. I'm trying to get a new page here. How do I get a new page? Would it be like that? No. Would it be like that? No. Okay, how about, I'm just going to erase it and start over. Okay, so let me go back and put the permutations formula back up on the board. So I have P N R equals N factorial over N minus R factorial. Well, let's understand what the N and the R stand for. The N right here is the number that you're going to start with, the number to choose from. Okay? So in this case, there were 4 floats that I have to put in the parade. The R stands for how many you're going to let take a spot. Okay? So how many you need, how many you will use. In this case, I'm using all 4 of the floats. So in this problem, the P is going to be, the N is going to be 4, and the R is going to be 4. So when I set the problem up, it would look like this: P 4 4, because I have 4 floats, and I'm going to use all 4 of the floats, equals N factorial. The N is 4, so 4 factorial over N minus R in parentheses, so 4 minus 4 factorial. So that gives me 4 factorial over 0 factorial. So this is the only thing that's kind of weird. You have to know what 0 factorial stands for. And this is a fact. Sometimes in math we have facts that you have to learn, like your multiplication facts. 2 times 3 is 6. That's a multiplication fact. This is a fact. 0 factorial equals 1. 1 factorial also equals 1. I had to Google that because I was like, why? Because, you know, I'm a why person. So I was like, why? Well, everything that I read, all the math stuff that I read on it said, because if 0 factorial didn't equal 1, then the problems wouldn't work out. That's what it said. I was like, oh. Okay, so for this problem, it made me laugh, because if it didn't, it has to be. So 4 factorial means 4 times 3 times 2 times 1, and then 0 factorial is just 1. And we've already calculated 4 times 3 times 2 times 1, which is 24. Okay, so the formula works, as well as if you want to just kind of use your common sense. So let's try one where the N and the R aren't the same. Let's look at that. So suppose that I had, I'm going to make a password, okay? So my password, I'm going to say it's going to be 5 characters. So that means I need 5 things, right? And I'm going to choose from the alphabet. So it can be anything in the alphabet. Okay, so 5 characters. Now remember, a password. In a password, the order matters. When you type your password in, can you just type the letters in however you want? No. You got to type the first one in, the second one in, and so on. So the order matters. So this one is going to be a permutation. Now, the N is how many things I'm going to get to choose from. How many things am I going to get to choose from for this problem? How many letters are in the alphabet? 26. 26. You will have some problems like this, so you do need to know that there are 26 letters in the alphabet. Okay, so then how many things are going to be in my password? 5. Only 5. Okay, so my formula says to take the n, which is the first, okay, so 26 factorial over 26 minus 5 factorial. So I'm going to simplify. So 26 factorial over 26 minus 5 is 21. 21 factorial. So if I wanted to, I could write that all out. 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15. And then the bottom, 21, 20, 19, 18, 17, 16, 15, right? But am I going to have some repeats in there? Okay, so where is it going to start repeating? At 21. So I would have 26 times 25 times 24 times 23 times 22 times 21, but that would be everything under 21, so let's put that little factorial right there, over 21 factorial. Well, I can cancel out the same exact factorials. So those 21 factorials will cancel out. So somebody get out your calculator. How many ways can I write that password? Somebody multiply 26 times 25 times 24 times 23 times 22 for me. And what do we get? It's going to be a big number. So 26 times 25 times 24 times 23 times 22. I'm waiting. Did you get it? On what? Are you multiplying mine?
Yes, I am, but
okay, 26.
7,893,000.
Okay, well tell me it again. 7,893,600.
See, this is stuff about math down, like
600 what?
that's what I'm saying.
why would you come up with that big of a number? Like
Okay, so y'all, if you think about this, when y'all make y'all's passwords, y'all think about this. That's why passwords are hard to steal. You know, unless somebody sees you put your password in. But most of the time, you can use all the letters of the alphabet, right? But then you can take all those letters of the alphabet and you can capitalize them. Okay, so that's a whole nother realm. And then they, a lot of times, want you to put a number in. So then you got the numbers. And then they want you to put a special character. So if just using the letters of the alphabet, there are 7,893,600 different ways to make that password. Think about if you put all those other things in. So passwords really are hard to steal, although computer programmers are good at, making a code to steal them. But anyway, so that is how those work. Does everybody feel better about that? So, Kanisha, you could do it like kind of common sense, with a picture. There would be 4 choices, 3 choices, 2 choices, 1 choice. Or you can use the formula.
Okay.
Okay?
All right, thank you.
You're welcome. All right.